Okay, Dr. C number 1 from homework 9 is a center of mass calculation problem. So what you've got, and let me draw it neatly here, is let's do this. You've got a arc of a circle, okay, centered about the y-axis. And this has a radius r and an overall angle theta, and you're asked to calculate the position of the center of mass of this, and then look at some extreme cases where when theta goes to 0 or theta goes to 2 pi. Theta goes to 0 corresponds to just a point particle here, and 2 pi is a complete circle, and you should know the answers for those without calculating, but it'll be a good check on our answer. In any case, we need to calculate the center of mass of this piece of arc, but what we know or have to base this on, well, first of all, you can use symmetry to say that because this arc is symmetric on left to right about the y-axis, mere symmetry, or if you like, or rotational, that the center of mass has to lie somewhere along the y-axis. So that means all we have to do is calculate how far up along the y-axis it lies. So what we're really after is the y component of the center of mass, because the x component will be 0. And that y component will be given by a general formula, integral of y dm divided by the integral of dm, or the total mass. Okay. Now, that means we have to break up this arc into small chunks dm, okay, and then add up all those small chunks, actually integrate over the chunks. So how do we do that? Well, it's an arc, and you should remember from high school that the length of an arc is given by r theta, and that means I can break this up into a small element of mass dm, and I will know the amount of mass if I know the mass per length of this arc and multiply that by r d theta, which is the length of the arc. Okay, so this arc, little piece of arc, has a length ds, if you like, equals r d theta, and lambda is the mass per length of the arc. Now, we aren't given lambda, and we aren't given the mass of anything either, but my hope, and actually I know, is that lambda will divide out of the final answer, because lambda is going to appear both in this term and that term. So I can just make up some symbol, and we know the symbol for mass per length of the material from which the arc is made. Just call it lambda and use it, and then hope that it divides out. And if it doesn't, then we know we didn't have enough information to solve this problem. Okay, so now that I've got this done, okay, I have to decide how to add up all the pieces of this arc. And to do that, I'm going to define another angle, phi. Okay, so phi will be the measurement of the position of this slice dm as an angle from the y-axis. Okay, and I need to have that. You might think I want to just integrate up y, but that'll turn out to be an awkward way to describe where things are here. It's very natural to say, oh, I can go from here to there just by varying the angle phi instead of varying the y, because that'll get you involved in the square roots of r squared minus x squared, etc. It will be a bit of a mess. You can do it that way, but it's going to be a lot harder to solve the problem. So what I want to do is integrate over the angle phi, as phi goes from negative theta over 2 to plus theta over 2. The far left position to the far right position, which is the overall angle theta. And I'll be integrating up, well, first I have to integrate up y. Now, what's y in terms of r? Well, here, let me just draw it over here, bigger, in case that helps. This is r. This is a variable angle phi that I've defined. The height above the x-axis is just this length, which is just r cosine phi. So I'll have the term r cosine phi. Remember, that's just the y in this equation. Then I'll have the dm term, and the dm term is just my lambda times my r d phi. So that's dm. Y, let me write it here for you. Y dm. Then I have to divide that by the integral of dm, but that's the same integral basically, as phi goes from negative theta over 2 to plus theta over 2. And now it's just dm. There's no y term, so it's just integral of y r d phi. Okay. We actually already see, well, let's just go ahead and do this step by step. So the y component of the center of mass now is equal to, now the constants here are lambda r squared and lambda r. I could take these outside the integral and note that the lambdas cancel, as I had hoped and planned. The r squared divided by r will just leave me with an r. So I have this as r times the integral from negative theta over 2 to plus theta over 2 of cosine phi d phi divided by the integral over the same limits, negative theta over 2 to plus theta over 2 of just d phi. And these are hopefully easy integrals for you to do. I'm left with r, and the integral of cosine theta is sine, or cosine phi is sine phi, which I have to evaluate from minus theta over 2 to plus theta over 2, divided by phi, evaluate over the same limits, plug these in, so that's sine of plus theta over 2 minus sine of negative theta over 2, but that's just equal to, since the sine of plus theta equals the sine of minus theta, that's just equal to the sine of, or 2, let me write this way, 2 times the sine of theta over 2. And if you plug in these limits, you'll just have theta. And that's the answer. And just rewrite it this way and circle 2r sine theta over 2 divided by theta. Okay. And that's with theta in radians. You can convert to degrees if you want, using theta radians equals theta degrees times pi over 2, 180, but I won't do that here. It's in the written solutions. Okay, so let's just check our answer, because it's not obvious. Just glancing at that, what you're going to get. Okay, so the checks that you were asked to do or required to do, well, for theta about 0, that just corresponds to a little point up here, and so the center of mass should be up there too at y equals r. And what does our formula give you? Well, we have y center of mass goes to 2r. We can use the small angle approximation, that for small angles in radians, theta in radians, remember, the sine of the angle equals the angle itself. So this just becomes theta over 2 divided by theta. Theta's cancel, 2's cancel, r. Check, just as we expected, as though it were a point particle at that position. Okay, the other check that you're required to do is what happens as theta goes to 2 pi, which corresponds to a complete circle, and then from symmetry we know the center of mass should be at the middle. But what our formula tells us is that y center of mass goes to 2r sine of, well, theta is pi over 2, so this is just pi then. And then it's divided by theta equals 2 pi. And the sine of pi is 0. And so again, we have the answer that we expect. And we've done our 2 checks, and we're done.